3.4. We can go over any of those that we want. So we are in section 3.6, actually. We talked about, on Monday, we talked about section 3.5, which is we just learned what a matrix was, right? And we learned that you can add and subtract matrices together to produce new matrix. And I think everybody felt pretty comfortable with that. Remember, the biggest thing is that if you're adding or subtracting a matrix together, you have to actually, sorry, I'm trying to get the chat up at the same time. I apologize. There we go. You have to have the same size matrix in order to be able to add and subtract. There it says that the two matrices must be the same size to add or subtract. And when I'm talking about size, I'm talking about the number of rows and the number of columns. So this is a 2 by 2 matrix plus a 2 by 2 matrix, and that equals a 2 by 2 matrix. Okay. We can also multiply by a scalar. That's when we have like number out front. And that just basically means that we multiply every term in our matrix by that number. And so if we have a 2 by 2 matrix multiplied by, like this is the number 2, but it could be any number, it could be 10, then we have our result is another 2 by 2 matrix. Okay. This matrix up here would actually be a 2 by 3 matrix. We always name it by rows and then columns. So this is a 2 by 3 matrix. So that is important to know the size of a matrix because that lets you know what you're allowed to do with the matrix. Okay. So then everybody felt good with that. We did some examples. We even solved with a matrix equation. And then at the end of class, we talked about what happens when you multiply two matrices together. Okay, so I did an example of this, but basically what we need to have when we multiply two matrices together is the first thing you have to do is figure out, can you multiply? And if you can multiply, what the result's going to be. So what I mean by that is that this first matrix right here is this is a 2 by 3 matrix. Okay, and our second matrix is a 3 by 2. Okay, this has 3 rows and 2 columns, so it's a 3 by 2. So in order to be able to multiply two matrices together, the number of columns of the first has to equal the number of rows of the second, which it does, right? We have 3 columns in our first and 2 rows in our second. So those match up. These two have to match, okay? And then your end resulting matrix is these outside numbers here. So our answer is going to be a 2 by 2 matrix. All right, so just to kind of make sure you guys get it, if I had a, let's see, if I had a 5 by 2 matrix, so I have 5 rows, 1, 2, 3, 4, 5, and 2 columns, okay, 5 by 2, and I'm multiplying that by a 2 by 3 matrix. Okay, 2 by 3 matrix. First of all, can I do that? So what do you guys think? Can I do that?
Yeah.
Yep, I'm allowed to do that, right? Because the 2's match up. And then what is my answer? What is my answer of my matrix? The size of my solution to this?
5 by 3.
Yep, this is a 5 by 3. So that's kind of the first step, is knowing how to do it. And then the second step is, how do I actually multiply? Sorry, you're going to probably hear me drinking today, so don't sound so crazy. So to multiply a matrix by another matrix, we do something called the dot product of the rows and columns. So I kind of showed you an example of one of these, but I want to just do some more examples of that. And do I have any? I don't have any great examples on here. So let's go to the book and see we have 3 through 17 and then 23 through 29 odd. Use the calculator. So let's grab one of these. I'm going to have my book right here. So oops, don't save. Sorry. I was looking in my book. Sorry. Okay, so let's do number 15. Okay. So number 15 is it has 5, 0, 1, 2, -4, and 6. Can anybody tell me what size matrix this is?
3 by 2.
Yep, this is a 3 by 2, right? And then I have 3, 7, -2, 0. So what size is my second matrix?
2 by 2.
2 by 2, right? And so then when I multiply them together, or what, can I multiply them?
Yeah.
Yeah, I can because these match up, right? My answer is going to be what? What size is my answer going to be?
3 by 2.
Yep, it's going to be a 3 by 2 because I take my outside numbers. Okay. All right, so I'm going to do this and I'm going to explain kind of every step how I end up with what I am. And I think that if you kind of name what position you're in, it helps you figure out what you need to multiply. Okay, so what I mean by that is I'm going to have a result that's going to have 6 different numbers, right? Because I have 3 rows and I have 2 columns. Gotta find what color didn't I use? Red, orange, yellow. There we go. So I'm going to have 6 results, okay? So if I look at my purple square, that purple square is the first row, first column. Okay, this purple square is in my first row, first column. So that means I'm going to multiply my first row by my first column. Okay, so what that looks like practically is like I'm basically going to kind of take 5 and 2, and I'm going to move it sideways, and I'm going to do 5 times 3 plus 2 times -2. So another way I'm going to write that 5 times 3 plus 2 times -2. Okay, so it's kind of like I wish I had my hand so I could kind of show you. You kind of take this guy and move it sideways to multiply across. So when I do that, I get 15 plus -4, which is 11. So my end result is 11 for that one. Okay, so now I've done one. All right, so now let's go to the orange square, right? The orange is my second row, first column. So now I go to my second row and my first column. Okay, and I'm going to do the same exact thing. So it's going to be 0 times 3 plus -4 times -2. It's kind of like I wish I could take my hand and kind of show you. It's kind of like you take this guy here, right, and you flip it sideways and do the multiplication. So you end up with 0 plus 8, which is 8. Okay. Then I keep going. My green is in my third row, first column. So third row, first column again, right? So green would be 1 times 3 plus negative 2 times 6. That's 3 plus negative 12, which is negative 9. Negative 9, right? Okay, so now to red. Red is in my first row, second column. So again, first row, second column. So red is going to be 5 times 7 plus 2 times 0. So 5 times 7 is 35 plus 0 is just 35. All right, now you guys tell me what the gray one's going to be. Try gray. See if you can figure out what that's going to be. All right, Otto says 0. I agree with Otto. So this is your second row, second column. So second row, second column, right? So you're going to get 0 times 7 plus negative 4 times 0. And you end up with 0. All right. And then what about my last one, my yellow? What's yellow going to end up being? Otto says 7. I agree. So the yellow is in your third row, second column. So third row, second column, which would mean 1 times 7 plus 6 times 0, which is 7. So now you've multiplied your two matrices together. You get 11, 8, negative 9, 35, 0, 7. Okay. I want to know, how do you guys feel about this? Do you feel like you got it after we talked about it on Monday and today, or do you think you would like to see another example just to kind of connect the dots? Everybody's quiet today. Um, Here. How about I put number 13 on here and you guys try it and see if you get it. Because sometimes until you try it, you don't know if you are actually getting it or not. Okay. So here's number 13 from your homework, and it is 9, 0, negative 3, 2, and 0, 1, 4, negative 2. All right. So I want you guys to try it and tell me when you got it done, or if you get stuck. I'll be right back. Okay, I'm back. All right. Is everybody doing all right? Like anybody stuck? Anybody done?
I think I got it. Yeah.
All right. How about everybody else? You guys still working on it? All right, I'm going to give you guys one more minute and then I'll go ahead and make sure that we all got it. Okay. All right, so if I multiply these two guys together, right, I can multiply them. This one's a pretty easy one to tell because it's 2 by 2 times 2 by 2. So they all match up, right? And your answer is going to be a 2 by 2. All right, and so when I do my first row, first column, I end up with 9 times 0 and then negative 3 times 4. So negative 12. Okay. My second, well, let me go. My second row, first column is going to be 8. Okay. My first row, second column is going to be 9 times 1 plus negative 3 times negative 2, which is positive 15. Okay. And my second row, second column is going to be 9 plus 6. Sorry. No. My second row, second column is going to be 0 plus negative 4, which is negative 4. Okay. So if you can do that, you should be in pretty good shape for the first part of the homework. The second part of the homework is number 23 through 29 is kind of like I showed you guys on Monday, especially the people with the TI calculators. They give you four matrices. They give you matrix A, B, C, D, and E, and then they ask you to perform a lot of operations on those matrices. Okay. Um, so you can, again, do these by hand. Completely possible to do these by hand. But like I said, if you want to, you can use your calculator for 23 through 29. I wish I could pull up the page on here. Wonder if I Google that page, if it would show up. It's always, let's see. Algebra 2, page 200. Probably not going to work, but no, I don't think that's going to bring it up. Well, if you have your book, I'm going to be on page 200. Like I said, I think it's easier to do this on your TI. So on your TI, you're going to do this. What it basically looks like is there's 5 different matrices at the top of page 200. It tells you matrix A equals this, matrix B equals that, C, etc. So I want to show you how you can do this in Desmos, but also my TI people, you can do this the same way that we did in class on Monday that I was showing you. So what I mean is that first we have a set of matrices. We have 5 different matrices. So let's go ahead and define them all. So if you're using your TI calculator, you're going to go into matrix and you're going to go under the edit part. And for matrix A, the book tells you that matrix A equals 5, -3, -2, and 4. Okay. So in Desmos, for this Desmos matrix thing, it's not in the app, it's only under Desmos/matrix. You go to new matrix and you add a new matrix in. If you're using your TI, you go under the matrix button and you hit edit for matrix A and you put in your 2x2 matrix. Okay. And then I want to add my second matrix in, which is B. So I add a new matrix and I'm just looking at my book, and B is another 2x2 matrix. So I want to add that in. And that is 0, 1, 4, and -2. Okay. And then you can keep going. There's 5 different matrices there, so if you define them all. Now, if I then want to do problem like number 22, which is 3 times matrix A times matrix B, I can just do 3 times matrix A times matrix B. And then your calculator can evaluate that based off of what you've put in. Or if you wanted to do 1/2 of matrix A times matrix B, you can do that. I see that number 24 is, well, I'm going to do a modified or it's matrix A times matrix B minus matrix B times matrix A. Nope, not C. B. Okay, so that means that I need to multiply A times B and subtract that from B times A because these are 2 different numbers. A times B is one matrix and B times A is a different matrix. They come up with a different solution set. So that's how we use a matrix calculator to help us calculate. Okay. Does everybody feel comfortable using some kind of a matrix calculator, whether it be Desmos or your TI, to calculate?
Yeah.
Okay. Everybody else feel comfortable? Or is it something you guys need to play with and kind of see? Okay. Well, okay, cool. If you have any questions about how to use your calculator, definitely bring them on Monday, okay? Okay, we're going to keep going. So that's 3.6. You're going to practice multiplying matrices together, okay? Now, you'll notice that your 3.7 and 3.8 is kind of all smushed together, okay? Um, and that's because we're going to learn about something in 3.7 called the determinant. And you're going to be like, why do I have to know what this thing called the determinant? And the determinant is important because it helps us find the inverse of a matrix. And then you're going to say, why is the inverse of a matrix important? Well, the inverse of a matrix is important because it actually lets us solve those big, crazy equations where we have three variables and three equations. Okay, so basically, I'm going to talk you backwards. We had to learn what a matrix was, right? We did that. Once we learned what a matrix was, we had to learn that we can add, subtract, and multiply it together. Okay, so we're good with that. We did that. Then we have to learn how to find something called the determinant. The determinant lets us find something called the inverse. Okay, and the inverse lets us solve equations an easier way than by hand in 3.4. It lets us to solve equations using matrices. Okay, so I want to let you know why we're learning all these things. I'm not just telling you what the determinant is, what the inverse is. It actually kind of helps us build up to the point of being able to solve equations. Okay. All right. So the determinant of a matrix is kind of written out here. I'm only going to have you do determinants of matrix by hand for 2 by 2 matrices. Okay. The first thing to note is that you can only find the determinant of a matrix if it's a square matrix. What do you think a square matrix means? A square matrix, yeah, 2 by 2 would be one. A square matrix basically means that it has to have the same number of rows and the same number of columns, right? So a 2 by 2 is a square matrix, a 3 by 3, a 4 by 4, 1 by 1. Those are all square matrices. Okay, so the determinant only works for a square matrix. Here we go. There's my notes. And it's this word here, determinant. Okay. It only works for a square matrix. And here's how it basically works. If you were to have a matrix that it looks like this, you have it's A, B, C, D. And I know it's written a little bit weird here. So, but it's A, B, C, D. To find the determinant, you're going to multiply A times D, and then you're going to multiply B times C, and then you're going to subtract AD minus BC. Okay, so let me pick some real numbers so you can see what this looks like. So if I have some matrix A, okay, and A equals 1, 3, -2, 5, okay, and I asked you to find the determinant of that matrix, okay, so the determinant of the matrix is you take 1 times 5, and then you subtract 3 times -2. So the determinant of this matrix will be 5 minus a -6 or +11. The determinant is a number, it's not a matrix. Okay? So 1 times 5 minus 3 times -2. Okay, so it's not too hard to do to find the determinant, right? when you have to find the determinant of a 3 by 3 matrix, which I'm not going to have you do by hand. So 2 by 2, I think you can easily find the determinant of. 3 by 3, you can do, but it's just kind of a little bit more work. I just want to let you know how you do that. So if you have a 3 by 3, what you kind of do is you take A by itself, and then you find the determinant of the leftover matrix. Can you see that here? You have A, and you multiply it by the leftover matrix. And then you have B, and you multiply it by the matrix that's not in the column of B. And then you have C, and you multiply it by this leftover matrix. And then you subtract and add to kind of come up with this whole formula how to determine it. Okay. Again, 2 by 2, I think you guys can definitely do 2 by 2 matrices to find the determinant. 3 by 3 is a little bit more complicated. I'm happy to show you how to do it by hand, but we do have matrix calculators that let us do it. Okay. So, for example, since I already have it plugged into Desmos somewhere, what if I wanted to find the determinant of matrix A right here? Okay, so let's see if we can do it. Okay, so matrix A is 5, -3, -2, 4. Okay, and I wanted you to find the determinant of this matrix. So the determinant would be 5 times 4 minus -3 times a -2. 5 times 4 is 20 minus -3 times -2 is 6. So the determinant would be 20 minus 6, which would be 14. Okay. If I wanted to find the determinant to use a matrix calculator, you'll see in here, there is a button on Desmos. It says DET for determinant. So if I said the determinant of A, then it's going to calculate what the determinant is, which is 14, which is what we just calculated back here, right? So we did it right. If you wanted to find the determinant on your TI calculator, let me get out my TI calculator. You're going to put, again, you have to name the matrix, right? You got to put it in under edit and make sure matrix A is right. And then once you have that in there, if you go hit matrix and then that middle column that's called math, the first thing is the determinant, the DET. So if you have matrix and you hit math, determinant, and then you put in A, just making sure, then it will determine the determinant for you. Okay. Everybody feel okay with that? Do you think you can do the determinant of a 2 by 2 by hand?
Yeah.
Yeah. Okay. And do you think you can do the determinant of a 3 by 3 in a calculator?
Yeah.
Yeah, that one we can do, right? Either of them in the calculator. Okay. Last thing I'm going to show you today, and then we're going to wrap this up on Monday. So I want to go over it one more time because it's like new information. So I will talk about the determinant and the inverse again. And then we'll get to why. So this idea of the determinant, it's like, okay, great, I got this number. Why do I need it? Well, the determinant lets us find the inverse. Okay, so just before we even talk about the inverse of a matrix, let's just talk about what the inverse is. So like if you have a very, very simple math problem, what color do I want to use? Purple, sure. All right, so if I have a very, very simple math problem and I have 3 times x equals, I don't even know, 12. Okay. I know that you guys all know how to solve this. You can tell me what the answer is right off the top of your head. But if you really, really break it down, if I multiply both sides of my equation by the inverse of 3, which is 1 over 3, then I can solve this problem, right? I get x equals 4, which you guys knew at the beginning, right? But this idea of multiplying by the inverse is really powerful. The inverse lets us do a lot of things in math. A lot of times we don't realize we're even doing the inverse, but that's what we're doing. So now we're taking that to a much higher level and we're trying to find the inverse of a matrix because that lets us kind of turn the matrix into an equation and undo it. All right. I know it's very exciting. Can't wait to find the inverse of a matrix. So when you have a 2 by 2 matrix, right, like this, and you want to find the inverse, and that's indicated by a little -1. You might even have that's on your math, on your calculator, right? You want to find the inverse of a 2 by 2 matrix that's A, B, C, D. What you do is you switch the matrix around. So you switch A and D and you make B and C negative. And then you have to multiply the whole thing by 1 over the determinant. It's clear as mud, right? So I want to find the inverse of a matrix. I'm going to do this little kind of formula thing here. Okay, so let me steal this. Copy to clipboard. Go back to here. This is my A that I had in there, right? This is how I'm going to find the inverse of my original matrix. Okay, so this is my original matrix up here, right? The inverse is going to be, I switch D and A, which are these two guys. I switch these two values. So now 4 goes up here and 5 comes down here. Okay, and then I make my B and C position, I make them positive, or I make them negative, which in this case makes them positive. So 3 and 2. And then I multiply everything by 1 over the determinant, which is 14. Okay, so the inverse of this matrix, the inverse is going to be 4 times 1/14. So 4 over 14, 3 over 14, 2 over 14, and 5 over 14. I promise this has a point, not just to torture you with lots of different matrices. Okay, if I go to my matrix calculator now, wherever that guy is, and I ask the matrix calculator to find the inverse of A, which looks like this, it gives me these numbers. I don't know if I divide, where's my math problem here? What is 4 divided by 14? Let's see. 4 divided by 14 is 0.2857. So in my matrix calculator, I got 0.2857. So that worked out okay. All right. So the whole idea of this matrix is that if I actually take my original matrix and I multiply it by the inverse, I get something called the identity matrix. So basically, when you multiply a matrix by its inverse, you end up with the number 1. And it's actually a really powerful thing that you can do that. Now, I kind of haven't gotten to why it's powerful, but, and we'll talk about that on Monday, and we'll again talk about all this again. But I just want to let you know that we're going to find the determinant, which is going to let us find the inverse, and then the inverse is going to actually let us solve these complex problems. So if you feel like a little bit confused like that, it's okay. I want you guys to see it one time. And then again on Monday, when we see it again, I think it'll kind of help clear up what we're trying to do. Okay. So, does everybody feel like that everybody was okay with finding the determinant, right? So, for your homework so far, you should be able to go all the way up through 3.7. Okay. For for the 2 by 2 matrices, I want you to do them by hand. And for the 3 by 3 matrices, you can do those using a calculator. And then don't worry about anything in 3.8. We'll talk about that on Monday. Okay. And if you feel a little bit confused, it's okay. We're going to keep kind of looping back on this, and Monday we'll spend more time doing that. But try those out, and please bring any questions you might have on Monday to class. Okay. I think we're going to go ahead and wrap up there. I think my voice is giving out on me anyway. Um, so I hope you guys have a good rest of your day, and please let me know if you have any questions if you get stuck on anything, okay?
Okay,
Th
thank you.
Thanks, guys. Have a good rest of your day. I hope you feel better, Aaliyah. Bye, guys.